Hey, it's Dr. Pat, and we're looking at average rates of change today. So basically, when you see the rate of change word phrase, basically one of the key things you want to be thinking about is that it's slope. So we'll be talking about slopes. So if we look at rates of change, then we are talking slopes. Okay, so looking at rate of change, slopes. And those are the different ways that we've seen slopes. You remember change of y's over change of x's. That's the one on the left-hand side there. Or delta. The little delta symbol just means change for us. So the change of y over change of x is that's another way of saying it. And then also the more formal way of doing slopes is using that function notation. So just remember that f of x, too, there, that's just the second y value. Okay, just means you have to do a little work. You have to do the calculation of the y value while you're doing the calculation of the slope. Okay, so I'm going to do a dorky example here about how we can use the slope idea. I've got a situation where, oh man, this one class, it's really boring. It's crazy. Students are complaining to the dean because everybody's just falling asleep. It's the most boringest class ever. And so the dean goes into the class, watches it, and makes a chart of the percent of students who have fallen asleep. Now, that's a mixture of students. Some students are waking up, others are falling asleep, but it's the combined percentage of students that have fallen asleep during this class period, this 50-minute class period. Okay, so that's what we're looking at. And so the dean shows the professor this, and so they're trying to analyze it and say, hey, prof, you gotta improve your teaching. But the prof looks at it and tries to defend himself, and so here's how the prof can do this. Now, this is legal, it's mathematics, but we can see that just looking at this graph's going up, indicating that more and more people are falling asleep, but then it falls down here at the end. Yeah, people are waking up to go to their other class or go somewhere else. So that's typical of what happens at a class. But I mean, the trend line surely clearly looks like things are looking bad. But here's what the professor says. Now, just remember, when we're analyzing this, just remember that rate is equal to slope. And so the professor can do a really quick analysis and say, hey, dean, it's not so bad. Because during the whole class period, students have only fallen asleep at a rate of 0.3% per minute. Okay, so that's a 50-minute class period at 0.3%. That's only like 15% total at the end of, for the whole class period. So what's the big deal? Okay, and so you might be looking at that as like, whoa, Pat, how are you getting a rate, such a small rate of 0.3% per minute? Oh yeah, remember? Rates are slopes. And so that little fraction line or the per word, that's key. Per word is key here. And so just keep that in mind when we talk about this. So you'd be wondering like, well, Pat, how can I get this kind of low rate when clearly people are falling asleep? Well, how about if we're using this overall rate, that's from time 0 to time 50, the overall rate of change, and that would be the slope from time 0 to time 50. If I use that for my calculation, that's how I get 0.3%. Okay, so one of the ways that somebody can kind of reduce the impact of this up and down kind of thing is to use what we call an overall rate. And rate is just slope on a graph. Okay, so that's one way, but the dean's not going to fall for it. Or here's I got to go to this Dow Jones example because you might be going like, well, Pat, that's just a dorky example of students falling asleep. How could I really use it in my real world life? Okay, and so how about a Dow Jones? Dow Jones. You got a stockbroker or something like that taking care of your investments because you're all going to be making the big bucks. You're going to have this extra money. You need to invest in the stock market, and so back in way back when, around 2008, 2009, we had a really bad time here. Our stock market just went down straight bad. And that's a hard thing for a stockbroker to kind of convince their clients that like, no, I protected your money, I made you money or something like that. Well, here's how one way that a stockbroker can say, hey, I know times are bad, but I was able to earn you an average rate of $134 per year on that investment. Well, what he's really using, he's just using the slope, okay, using that overall rate. And that overall rate, once again, just loses all of that up and down information. So when you go from time 0 to your ending time, man, that is just you losing a lot of information. And so that's what I want you to be aware of. Don't let anybody try and convince you of something when using the overall rate because they're losing a lot of information. Okay, so just kind of, that's how you could use this stuff. All right, so now another way that this professor can argue, hey, it's not my fault. Students are coming in sleepy. You might be thinking, well, what's that got to do with anything? Well, if you look at the beginning of this graph can, it's got a nice little straight up there. So people are coming in and they're already starting to fall asleep within the first 10 minutes. So for the first 10 minutes, I got an average rate going from 0 to 10, and that's kind of indicating. But now look at what happens. If I go from that and combine it with this one going from 10 to 50, that 10 to 50 is a slope of 0. So just using those two slopes, if you didn't know what the graph looked like, and using those two slopes, those average rates, the professor could have argued, hey, first 10 minutes, they're coming in sleepy. I got a 12:30 class. It's after lunch. Everybody's coming in. Their stomach's full. They're just ready to fall asleep. And then I do this wonderful job that after 10 minutes to 50 minutes, nobody is falling asleep because I got a slope of 0. Okay, so that's the argument there. But once again, when we're talking about an overall rate, not an overall, we're talking about an average rate from time 10 to time 50, that's over a long period of time, and it's missing all this ups and downs kind of things. So it's really missing all that kind of stuff. But it is an average rate of a slope that's equal to 0, which does kind of interpret as nobody falling asleep. Okay, but we get to see the graph. We know that's not actually true. Now, one way that the dean is going to argue this so that the professor can't get around is we want to use smaller interval sizes because it keeps more information. Smaller interval sizes keeps the information around. So if we were to do the average rate of change over 10-minute periods, there's the first 10-minute period, and then there's the next 10-minute. Oh, that's still a positive slope. Well, there's the third 10-minute period, and it's still positive, and then the fourth period, and then the last one, the last 10-minute period is the only one going down. And then, of course, we can easily argue, well, that's just the end of class period. Everybody is just waking up and ready to go. But clearly the first 4 sections of 10 minutes, that rate of change of students falling asleep are all positive. And so that is an indicator that something is happening in that class and we need to do some professional development. All right. So key points I want to keep in mind is that when you're talking about rates of change, there's slopes. The interval size matters. The larger time intervals makes things fuzzy. You lose information and all your fluctuations get all washed out. Okay. So Dow Jones, very big example. When you do your all average overall rates of change, you're going to lose all that ups and downs. Same thing with some of your science experiments and things like that. When you do a regression line, you do an estimate of what's happening. What you get is you get a nice average that's in between the data points, and it kind of flushes out, it washes down all the fluctuations. Okay, so that's how we can use average rates of change. In my next video, I'll be doing a couple examples of how we do it with graphs, and then a follow-up video on how we can calculate with formulas. Thanks, and have a good day.